The quiz problem was to graph y equals quantity x minus 1 cubed times x minus 3 quantity squared times x plus 2 times x squared plus 3x plus 11. We note that we have an 8th degree polynomial. We'll get an x cubed out of this, an x squared out of this, an x out of this, and an x squared out of this. That gives us 3 plus 2 plus 1 is 6 plus 2 is 8. X factors when we multiply all this out, so we're going to have at least an x to the 8th term, and no more than that. So having an 8th degree polynomial, we immediately determine that the far left behavior is positive and the far right behavior is positive. Because the leading term of the whole polynomial when we multiply it out is x to the 8th, which is positive for either negative or positive x. Also, if x is a large negative number, we have the cube of a large negative, the square of a large negative, and the square of the large negative is positive. Cube of a large negative is negative, the square of the large negative is positive. This will be negative and this will be positive. So we'll have two negatives and two positives, and that's going to give us a positive. So when x is a large negative number, we're up. Similarly, when x is a large positive number, we're up. We have zeros, of course, at x equals negative 2, because that'll make this 0. That's here. At x equals 3, here. At x equals 1, here. This function has no zeros. If we set it equal to 0 and attempt to solve using the quadratic formula, we'll get a negative under the radical. The discriminant, in other words, will be negative, and we won't have a solution. So this one can't give us a 0. So we have zeros here, here, and here. Now the 0 at x equals 1 here actually occurs 3 times. We have 3x minus 1 factors in this function. What that does is it tells us that when x is near 1, all this stuff is going to be pretty much the same. And it's the x minus 1 that's going to be changing most significantly. So if this is nearly a constant number, we have something that's nearly a constant number multiplied by the cube of x minus 1. Well, if we recall the way the graphs of power functions look, if you have a perfect or a cubic polynomial like there, a cubic power function, this is the cube of x shifted over 1 unit to the right. So here we are shifted 1 unit to the right, and we have a graph that looks a lot like the graph of x minus 1 cubed, stretched by a factor that's equal to whatever these things multiply out to when x is equal to 1. Similarly, at x equals 3, we have x minus 3 squared, which is 0 at x equals 3. These other factors are going to be essentially constant if we get very close to x minus 3. So we have something that's very much like the graph of some number times x minus 3 squared. Remember that x squared would be a parabola with the origin at the with the vertex at the origin, so that x minus 3 squared would be shifted to the right 3 units and would be a parabola with the vertex at x equals 3 on the x-axis. X plus 2 is linear. We pass through x equals negative 2 in a straight line. And that's the way the graph's going to look.